Hello folks, we come back with the next video, that is the problem number 18 that we are going to take up from the miscellaneous. It says that show that the height of the cylinder of the greatest volume which can be inscribed in a right circular cone of height h and semi-vertical angle alpha is 1/3. They do tell us is 1/3 the cone and the greatest volume. So there are two things that we need to show if you carefully see. So the height of the cylinder has to be 1/3 that of the cone, that you have to show, and then you have to show the thing about the volume. So as we do always, let's get across getting introduced with what is all this, and then let's work out. So this is let R, H and alpha be the radius, height and semi-vertical angle of the cone. Of course it's given to us, but still. And then we will call maybe R and H as the radius and height of the cylinder. Now this very typical problem where we don't have we are not very clear as to what we have, but they've given us that the semi-vertical angle is alpha. Now we know that it's a volume that has to be shown, and volume we are going to face this issue that we have pi r squared h, where r and h are two variables. We have to get them converted in terms of 1. Now it's the cone which is standard and the cylinder is variable. So everything that happens in the cone is going to be standard. So that is going to give you something constant from there. So let's right away get across with that. They have given us a semi-vertical angle alpha. If we could name this A, B, C, D, E. So you could look at tan alpha from say in the triangle, or maybe ADE. I think we could write that so that it could be clear as to how you're getting this. In triangle ADE, if you're looking at tan alpha, that tan alpha is R over H. And so also you could look at the triangle ABC. There tan alpha would be capital R over this part AB. AB is the entire H minus H. Yeah, so both are tan alpha, so they can be equated. So we can have maybe tan alpha to be equal to R over H, and can be equal to R minus H minus H. You can see that in the volume that they have asked, they have used quite a lot of tan alpha. So we are on the right lines. So now as we know that pi r squared h, we need the substitution. So with that in mind, let's look at this. R over H minus H is tan alpha, or rather H minus H is going to be R cot alpha, because this goes on the other side. And then in order to get H, it is going to be H minus R cot alpha. So that is one part of the work. Now let's look at the volume of the cylinder. Let's call it as V, and that is going to be pi r squared h. So here we are planning to keep r as a variable and substitute h, because you've got h over here, h minus r cot alpha. So that's going to be pi h r squared first one, and pi cot alpha r cube second one. So you've got everything in terms of r, so we can go in for the derivative, dv over dr. First derivative, pi h 2r, and this is pi cot alpha 3r squared. So and also the second derivative, that is going to be 2 pi h minus 3 pi cot alpha and 2r. Now in order to get the critical point, let dv over dr be equal to 0. So that will make 2 pi h r to be equal to 3 or maybe minus 3 pi cot alpha r squared equal to 0, where you can have the pi and r common. So you are left with 2hr, 2h minus 3 cot alpha r. Yeah, because we have it common. Now pi and r, they both are non-zero quantities, so you can divide both sides by pi r. So when we divide both sides by pi r, you're left with 2h minus 3 cot alpha r equal to 0. So your r value, when we take it on the other side, is going to be 2h over 3 cot alpha means r tan alpha. So that's your r value, and that's your critical point. So we can quickly check the maximum at r equal to 2h tan alpha over 3. So that is, let's see now what we're getting. We're getting 2 pi h minus 6 pi cot alpha r for us is 2h over 3 tan alpha. Now this will become 1 and 3 can become 2. So we are left with 2 pi h minus 4 pi h, which is minus 2 pi h less than 0. So therefore maxima occurs. Now, not only that, now there are 2-3 things. So we are done with the maxima, but then they have asked us 2-3 things. One is about the volume, and our next thing is about the height. So let's look at the height part of it and see how we can work it out. They tell us that r is this. So let's go from 1. What do we get here? H is h minus r, which is 2h over 3 tan alpha times cot alpha. That's from 1 that we get. And tan alpha, cot alpha, they are reciprocal ratios. We know that it will, if they get multiplied, it will become 1. So you are left with, this part is 1. So therefore you are left with h minus 2h over 3. So we can equalize times 3 times 3. 3h minus 2h is h over 3. So that's one thing that they ask us to show. H is h over 3. That's one thing to show. Another thing is maxima. Now about the volume. They ask us to show that volume is a certain thing. That also we will find, because we have all the things ready with us. So it's easier to find the volume. Let's find the volume. Yeah. Can we catch hold of the volume from here if you want? So therefore volume is pi h. R squared we know. Where is the r squared? R squared, yeah. So that is 4 h squared 9 tan squared alpha, and sorry, pi cot alpha r cube. Now r cube, let's do it carefully. 8 h cube 27 tan cube alpha. So you can have things common. Pi can be common, 8 squared can be common, 4 can be common, and 9 can be common. So that, and also you can have tan squared alpha common. So what are we left here? Pi, 4 pi h squared, h cube rather, h cube, 4 pi h cube, 9 tan squared alpha, everything is common. So here 1 is left. And let's look at what is left here. This one of the tan and cot, that will become 1, and the other 2 we have taken it out. So that is sorted out. 1 is there, pi is taken out. This is sorted out, and here 4 is gone, so 2 is left, and one more 3 is left here. 2, 3, h cube, everything is taken care of. Now let's see how we can sort this out. It is times 3 times 3, so that will be 3 minus 2, 1 over 3. So it's 4 pi h cube tan squared alpha. The 3 can multiply with this and become 27. Let's check if all the terms have come up or not. 4 over 27 pi h cube tan squared alpha. That's it. So that's what they ask us to show that the volume is this, and the volume is in fact this. That's all for this video. With more, now I think we have only the MCQs left. With that we can come in the following videos. And as I've told you that because there are deleted portions, the latest textbook will have a different numbering of the problems. So we'll have to check the question and then go in for the solution. So as always, please popularize the channel and spread a word. Thank you.